Well, there's a bit more to synaptic connectivity that I've told you earlier. For example, synapses are not always the same strength. Synapses can change quite dramatically in how they transmit information. So sometimes we see a very small response in the postsynaptic neuron. Sometimes we see a very large response in the postsynaptic neuron. So why is this? Well, that can depend on many things. One of the things is what we call short-term synaptic plasticity. Now, short-term synaptic plasticity just describes the fact that a synapse can change its strength within a short amount of time. We do know quite a bit about how this works, though. So let me tell you about it. As you might know, the neurotransmission between cells depends on the influx of calcium through calcium channels into the presynaptic terminal, which then releases the neurotransmitter via exocytosis of the neurotransmitter. Now, to strengthen the synapse, you can do a couple of things. For example, we can increase the transmitter release. Now, how do we do that? Well, we just need more calcium. So how do we get more calcium? For example, if there are two action potentials that arrive in the synapse within a short amount of time, so they arrive at the presynaptic terminal and depolarize the membrane. If the second one is close in time to the first one, the calcium that was released into the terminal that was caused by the first one will still linger around, still hang out. So when the second one comes around, you're adding that calcium on top of the first one, which means now you have a lot more calcium available. So if you have more calcium, you get more exocytosis and more neurotransmitter release, which means that the postsynaptic cell gets more excited. So there you have the strengthening of the synapse. If then there's a gap between action potentials, so there's a longer pause between action potentials, that calcium is being removed from the terminal, which means that a subsequent action potential that was not directly following the previous ones that this action potential will have a smaller effect again. So the amplification or the increase in the strength of the synapse is really only present if two action potentials arrive close in time. Now, by the same token, you can imagine how a synapse can be weakened. So, say an action potential arrives at the presynaptic terminal, and the calcium is introduced into the terminal. Now, when that happens, the calcium also has to be removed from the terminal, and that happens via calcium pumps. Those are proteins that pump the calcium out of the terminal, either into the extracellular space or, more typically, into the endoplasmic reticulum. Now, when those pumps are activated, they run for a certain amount of time. Now, the first action potential comes in, it elicits a certain calcium influx, and then the pumps turn on. So, the release from the terminal of the first action potential will not be affected by the pumping away of the calcium. However, now those pumps are activated, and now if a second action potential comes around, those pumps are activated already, so since these pumps are activated already, when the calcium from the second action potential comes in, means that the release of neurotransmitter will be smaller than before, which means that the synapse is now weaker. Now this effect also goes away if there's a longer pause, so it's also short term. We call it short term synaptic